This time I will be discussing one of the important topics in physics, is all about Doppler effect. Right, so what do you observe when you throw a pebble in a body of water? Okay, perhaps some of you may answer that apart from the pebble is sinking. You're right, of course. So Doppler effect, by the way, classmates, explain why we perceive a change in frequency when the wave source approaches or retreat from us. And what is Doppler effect? Now, Doppler effect is the change in frequency of a wave for an observer moving relative to its source. Say the observers, an upward shift in frequency when the wave source is approaching, and a downward shift in the frequency when the wave source is retreating or leaves us. And Doppler effect applies to all waves, including sound waves, light waves, and water waves. Doppler effect originated in 1842 by an Austrian physicist, Christian Doppler. Christian Doppler proposed the Doppler effect in his article, translated as "On the colored light of the binary stars and some other stars of the heavens." Now, Doppler's hypothesis was tested for sound wave by Weiss Ballot in 1845, who confirmed that the frequency of sounds pitch emitted was higher than the frequency when the sound source approaches him, and lower than the emitted frequency when the sound source receded from him. Hippolyte Fizeau found similar result in electromagnetic waves in 1848, and also John Scott Russell in 1848. Now, to understand the concept of Doppler effect, we must first understand the following. First is the wavelength, second is frequency, and the third is velocity. So let's come now to the concept of Doppler effect in wavelength. As we all know that wavelength is the distance between two successive crests of a wave, especially points on the sound wave or electromagnetic waves. So you can see the formula for wavelength is equals to the velocity divided by the frequency, where the sign here is a wavelength, and the v is the speed, and the f is the frequency. Frequency is the number of occurrence of repeating event per unit time. So in terms of waves, it's the number of waves passing a given point per unit time. So the unit of frequency is hertz. And velocity is the speed of something or waves in a given direction, when the formula is v is equals to d divided by the t, where v is the velocity, the d is the displacement, and t is the time. And the concept of Doppler effect on water waves. Imagine you are swimming with your friend Paul, and he is constantly bobbing his head up and down, creating a stream of wave, reaching you at the end of the pool. You observe that at every 2-second interval, 3 wave reaches you. As such, that the frequency of the wave observed is, frequency is equals to 3 divided by 2 seconds. So of course, it has 1.5 hertz. Now, you decided to call Paul to enlighten him on your brilliant observation. So Paul decided to continue his repeated bobbing, and as he approaches you, as he did, so you notice something else. Instead of 3, you observe 4 waves reaching you every 2 seconds. So the frequency observed is thus f, or frequency, is equals to 4 divided by 2 seconds, so it has 2 hertz. You got so excited about your find or result that you were speechless when Paul arrives. So Paul decided to return to his previous position in pool, still continuously bobbing. Paul lost focus on his intention and went past his original position. You detected his loss of focus and decided to call out him. But before you could, you notice another phenomenon. This time, instead of 3 waves per 2 seconds, you observe that only 1 wave reaches you every 2 seconds. So which implies that the frequency of waves approaches has declined. So therefore, frequency is equals to 2 seconds divided by 2 seconds is equals to 1 hertz. Another concept of Doppler effect is sound waves. This all about a siren on a police car, even an ambulance or a fire truck, which is our source, emitting a uniform series of sound waves, moving away from the source in all directions. So Jason distance away observing, or the observer, and the air is, of course, the stationary, which is our assumption. Now let's take the wavelength to be the frequency and the speed of sound to be the V. So V of the observer and the V of the velocity represent the speed of the observer and the source respectively. So the V of O is the speed of the observer and the V of S is the source of the speed respectively. So if both the observer and the source were stationary, he would observe a frequency equal to that of the source. So meaning to say, V of O, or the observer, and the velocity of the stationary is equal to 0. Now if the observer decides to walk towards the source, of course, what will happen? The speed of the waves in relation to the observer will remain the same. So therefore, the frequency observed by the observer is F is equals to V of the observer divided by the wavelength, which frequency is equals to the velocity plus the velocity of the observer divided by the wavelength. Since the wavelength is equals to velocity divided by frequency of the observer, can be expressed as frequency is equals to the V plus V of O divided by the velocity times the frequency. So frequency observed by the observer, what will happen will increase. Now if the observer decided to walk away from the source, the speed of the wave relative to the observer is velocity is equals to the speed, or the velocity minus the velocity of the observer, and the frequency is equals to the velocity minus the observed velocity divided by the velocity times the frequency. So what will happen now? The frequency heard by the observer in this scenario is decreasing, or will be decreased. So now suppose the vehicle or the source moving towards the observer who is at rest. Now since the source moving towards to the right, its successive wave is emitted from the position closer to the observer than the previous wave. So as a result, the wave fronts heard by the observer are closer together than they would be if the source were not moving. So the wavelength, therefore, measured by the observer is shorter than the wavelength of the source. So for every consecutive wave which lasts for a time interval, the source moves a distance, then the wavelength is shortened by this amount. So the wavelength of the observer is this one. This is the equation now. The wavelength equals the wavelength minus the change in wavelength is equals to the wavelength minus the velocity of E divided by the frequency. So in this equation now, the observer or the observed frequency increases as the source moving towards the observer. So conversely, if the source moving away from the observer, its wave is emitted from a position farther from the observer than the previous wave. So the arrival time between the successive waves is increased, reducing now the frequency. So the general effect, or the general Doppler effect now, is this one, this equation. Okay, so this equation applies to all conditions mentioned previously. The sign of the V of S and the V of O depend on the direction of the velocity. So positive value is used for motion of the observer or the source towards the other. The negative value is used for motion one way from the other. So let's come now to the application of Doppler effect. In the 1600s years or so, since Doppler first described the wave of phenomenon, that would cement his place in history, several practical applications of the Doppler effect have emerged to serve society. In all these applications, the same basic thing is happening. One of the applications of the Doppler effect found in nature occurs in bats hunting for their prey. Bats navigates its flight from emitting whistles and listening for the echoes. When chasing prey, its brain detects a change in phase between the emitted whistle and the echo is received. This tells that the speed of its target, and the bat adjusts its own speed accordingly. Another is the radar. The Doppler effect is used in some types of radar to measure the speed of detected objects. For example, a police officer uses radar guns to check for the speeding vehicles. The radar gun emits waves at a particular frequency, which, when it strikes the vehicles, bounce back towards the gun. The radar gun will measure the frequency of the return waves, then eventually determine the speed. The Doppler radar is a form of technology used not only by the law enforcing officer, but also by the meteorologists. Meteorologists utilize Doppler effect to determine the direction and velocity of the raindrops and wind direction and other weather events. This principle is very crucial as it allows the meteorologist to predict weather patterns including coming storm and etc. Now, in medical diagnosis, physicians and medical technicians apply Doppler effect to measure the rate and direction of blood flow in patient's body along with ultrasound. So, another is also Doppler effect is applied in flow of the measurement. In a light beam or an ultrasonic acoustic burst is released by the LDB or ADB respectively. This technique allows non-intrusive flow measurement at high precision and high frequency. Also used in satellite communication. And Doppler effect has found its use in several other areas, which includes astronomy, vibration measurement, to scene gesture, audio, and velocity profile measurement, etc. Okay, so that's all of my topic. Once again, thank you for listening and keep safe everyone. Thank you.